Greetings. Let me introduce myself as Brian C. Punsalan, and I am here to discuss about definite integration. So, are you now ready to listen? Okay, just sit back, relax, and I hope you will learn something from my discussion. Before we start our discussion with definite integration, let us first read our objectives of today's discussion. First is to discuss the concept of definite integration. Second is to solve using U substitution. And lastly, to solve using change of limits. So when you hear the words definite integration, what comes upon your mind? Okay, very well said. It is good when you have background knowledge about the said topic. So definite integration is defined as the difference between the values of integral of a function from the lower values of a to the upper values of b. So definite integration is different from indefinite integration. Notice that in indefinite integration, there are no intervals, while in definite integration, the lower limit and upper limit of interval is present. And in definite integration, the outcome or the final value is in numbers or it is specific, while in indefinite integration, the final value in terms of x is equal to f of x plus c, where big letter F is the antiderivative of small letter f. And notice that the constant c is still present. Definite integration basically is the integral of f of x dx from a to b is equal to f of b minus f of a, where big letter f is the antiderivative of the small letter f. Definite integration is exactly the limit of the area of a function and the x-axis. Let me show you an example. I'll just have to erase this one. We have here a graph representing a function and the x-axis with intervals on it. So the limit or the intervals a and b are present. So the outcome of the definite integration is only located in this area. So this is only the focus in finding the outcome of our function. So that is the concept of definite integration. It is to limit the outcome or the area of the function. To explain further, we'll have some illustrations to make it more easier. So we have here an integral of 4x squared plus 12x plus 9 dx with lower limit 0 and upper limit 1. So in order to solve this, we have to apply the rules of integration. So the integral of 4x squared is 4x cubed over 3. The integral of 12x is 12x squared over 2. And the integral of 9 is x plus c. So we have here the result of indefinite integration. But since we are aiming for the definite integration, you have to apply its formula, which is f of b minus f of a. Okay. F of b minus f of a. After applying this formula, you have to substitute the given intervals. Our upper limit or upper interval is 1 and our lower interval is 0. So our f of b is f of 1. Substitute the 1 to the given function, which is 4, and then substitute to the variables 3 over 3 plus 12, 1 over 2 over 2 plus 1 plus c. So after substituting, we have to simplify the function. So 4 times 1 cube is 4. So get 4 cube plus 12 divided by 2 is 6 plus 1 and plus c. And then simplify. We have 4 thirds plus 6 plus 1 is equal to 8 and 1/3. And then copy c. So now we have obtained our upper limit or our f of b. The next step is to get f of a or the lower limit, which is 0. So substitute. We have f of 0. Substitute 0 to the function. We have 4, 0 times 3 over 3 plus 12 times 0 squared over 2 plus 0 plus c. And then just simplify. So any number multiplied by 0 is 0. So we'll get 0 and then still 0 and then copy 0 plus c. And then simplify again. We'll get 0 plus c. Now we've got our f of b and our f of a. The next process is to subtract the upper limit to the lower limit, or f of b to f of a. So you have f of b minus f of a. Substitute. 8 and 1/3 plus c minus 0 plus c. The next process is to distribute the operation on the second term. So we have 8 and 1/3 plus c. This would be minus 0 and minus c. So notice that c will be cancelled. So that leaves 8 and 1/3 and 0. So our final answer would be 8 and 1/3. So notice that in definite integration, the final answer is in numbers or constant, while in definite integration, in final answer, there are still variable present. So this is another concept of definite integration. So I hope you have understand the discussion. We have examples here and we'll try to answer it using definite integration process. So number 1, integral of 4x squared of 16 minus x squared dx from 0 to 4. So this function is most suitable for u substitution process. So let u equal to 16 minus x squared. Our du or derivative of u would be negative 2x and our dx would be du over negative 2x. So after obtaining the values, we can now substitute it to the function. So integral from 0 to 4 is 4x square root of u, and our dx would be du over negative 2x. Notice that we can simplify 4x and negative 2x to negative 2, and since negative 2 is constant, we can move it to the front. So this would be negative 2, integral from 0 to 4. So our square root of u can be simplified to u raised to 1/2 to make it more easier to solve. So this would be u raised to 1/2 du. After such process, we can now integrate our function. So this would be negative 2 times the integral of u and 1/2 would be u and 3/2 over 3/2. And don't forget to put bracket because it is a must in definite integration. And then copy our lowest and upper interval. So that would be 0 and 4. So after integrating, we have to substitute the original term that we've used. So our u would be the original term, which is 16 minus x. So we have to substitute it to u in here. So that would be 16 minus x squared raised to 3 halves over 3 halves, and our bracket, which is 4 and 0. So now we can solve it by using definite integration. Or definite integration is f of b minus f of a, which f of b is the upper and f of a rather is the lower limit. So we'll have to substitute each interval to our function. So this would be negative 2. So we have to put bracket here times 16 minus our upper bracket, or FB, would be 4. So that would be 4 squared times 3 halves over 3 halves. So minus our lower limit, which is 0. So we have to put 16 minus 0 rather, squared times 3 halves over 3 halves. So that's parentheses. So the next process is to simplify our equation. So negative 2 times 4 squared is 16. So 16 minus 16 is 0. So 0 raised to 3 halves over 3 halves minus 0 squared is 0. 16 minus 0 is 16. So this would be 16 raised to 3 halves over 3 halves. So simplify again the equation. So that would be negative 2 times, this would be 0 because 0 divided by 3 halves would be 0, minus 16 raised to 3 halves divided by 3 halves would be 128 over 3. 128 over 3. So subtract the inside parentheses. 0 minus 128 is negative 128 over 3. And then for the final answer, you have to multiply negative 2 to negative 128 over 3. So negative 2 times negative 128 over 3. So that would be 256 over 3. 256 over 3. So this is the process of using U substitution in finding the definite integration of, or definite integral, I mean. So let us have another example. So we have here another example, and we'll try to solve it using U substitution and change of limits. So integral of x times x squared plus 1 raised to 2 dx from 0 to 1. So first we have to let u equal to x squared plus 1 and the derivative of our u, which is 2x dx, and then our dx would be du over 2x. So now we can substitute the values that we've got to the function. So 1, 0, This would be x times u squared. Our dx would be du over 2x rather. So we can simplify 2x and x so that will short to 1 half. So we'll move 1 half to the front. This will be 1 half integral from 0 to 1 of u squared du. So now we can now integrate the function. So this would be 1 half times integral of u raised to 2 would be u raised to 3 over 3. And don't forget the bracket of lower and upper interval. So after integrating, we have to substitute the original function to the u in here. So this would be 1 half times our u, which is x squared plus 1 raised to 3 over 3. And our bracket, lower limit is 0 and upper limit is 1. So the next step is to solve for the definite integration, which is f of b minus f of a. So substituting the upper limit and the lower limit to the function. So we've got 1 half times the x squared, the x of 1, our upper bracket, upper limit is 1. So 1 squared plus 1 raised to 3 over 3, and then minus our lower limit, which is 0. So substitute 0 to be 0 squared plus 1 raised to 3 over 3. So this would be the substituted lower and upper limit. So simplify, we got 1 half. So 1 squared is 1 plus 1, this will be 2 cubed over 3, and then minus 0 squared is 0, 0 plus 1 is 1 cubed over 3, and then simplify again. This would be 2 raised to 3 is 8. So 8 over 3 minus 1 raised to 3 is 1. So this would be 1 over 3. So simplify the inside parentheses. So this would be 8 over 3 minus 1/3. Should be 1 half times 7 over 3. So 7 over 3 times 1 half would be 7 over 6. So this would be our final answer in new substitution of the function number 2. We have here the same example, and we'll try to solve it using the change of limits. So we have let u equals x squared plus 1, du equals 2x dx, and our dx would be du over 2x. So substitute the obtained value to the function. X times u squared, our dx would be du over 2x. And then simplify x and 2x, that would be 1 half. So move it to the front, 1 half. Times, we can integrate our u squared, that would be u raised to 3 over 3. Times the bracket, and our lower and upper interval, which is 0 and 1. So unlike u substitution, that you will substitute your original function that would take longer process of solving, we have now to use change of limits to make it more easier. Instead of letting or substituting our original function, we'll have to let u in this integral. So we have to substitute the given x intervals to our u. So this would be u equals to x squared plus 1. This is our original interval, or original function rather. So we have to substitute our upper interval, which is 1. So this would be 1 squared plus 1. And 1 plus 1 would be 2. So this would be our new interval in terms of u. So now we have to substitute our lower interval. So this would be u equals x squared plus 1. So this would be 0 squared plus 1, and this would be 1. After substituting lower and upper intervals, we can now change our new interval in terms of u. So we'll have 1/2 times u raised to 3 over 3. In terms of lower interval is 1 and 2. So now we can use our definite integration solution. Unlike before, like we've had to substitute the original formula. So this would be 1/2. So our solution rather of definite integration is f of b minus f of a. So substitute, this would be 1/2 times our u cubed is, our f of b is 2. This would be 2 over 3. This would be 2 cubed rather. Minus our lower interval is 1. So substitute 1 cubed over 3. So after substituting the intervals, you can now simplify your answer. This would be 1/2 times 2 cubed is 8. 8 over 3 minus 1 cubed is 1 over 3. So simplify the inside parentheses. We've got 1/2 times, that will be 7 over 3. So after simplifying, multiply the outside term to obtain the final answer. So this would be 1/2 times 7 over 3. That will be 7 over 6. Notice that use substitution and change of interval or limits have the same final answer. It is just the process that we do to obtain it. It was different. The use substitution is a bit longer and more systematic, unlike change of interval. So this is my discussion about the definite integration, the concept, the examples of use substitution, and the change of limits. And I hope you have learned something from me, even though it was not that more, or that more and more. So thank you, and thank you for watching.